If the red supergiant star Betelgeuse were to explode right now, we would witness a cosmic event of unprecedented magnitude, a spectacle of the millennium. The sky would be set ablaze with an intensity that transforms the night into a brilliant day. Betelgeuse, known for its impressive size and reddish hue, is indeed on the brink of exploding. However, scientists remain uncertain about the exact timing. The term "shortly" could refer to tomorrow or extend to 1,000 years from now. In fact, it is possible that Betelgeuse has already exploded, and we simply have not seen it yet. The phenomenon of a supernova, where a star explodes at the end of its life cycle, occurs approximately every 50 years in our Milky Way galaxy. However, supernovae that are visible from Earth are a rare event, occurring roughly once every 1,000 years. Given Betelgeuse's distance of about 640 light-years from Earth, its eventual supernova will be of Type 2, a category known for its spectacular and dramatic displays. When Betelgeuse does explode, it will alter the brightness of the sky in a profound way. During the day, the explosion will be so bright that it could outshine the sun momentarily, creating an intense flash that might blind drivers and pilots, similar to a sudden lightning strike. This could lead to dangerous conditions, particularly at dawn or dusk when the sun is lower on the horizon, and the brightness of Betelgeuse's explosion could hit people's eyes abruptly. This extreme brightness would last only a brief moment, but it would be followed by the appearance of a new, extremely bright star in the sky. The new star would shine with such intensity that it would rival the brightness of Venus and Neptune, making it as bright as the full moon. This new celestial light could bathe the landscape in a surreal glow for weeks. During this time, the intense light from Betelgeuse would likely obscure nearby stars, rendering them invisible. While the certainty of Betelgeuse's eventual explosion is established, predicting the exact timing remains a challenge. Astronomers around the globe are closely monitoring the star with a variety of sophisticated tools. Some satellites are dedicated to observing Betelgeuse around the clock, capturing every minute change in the star's behavior. When the supernova does occur, astronomers and amateur stargazers will be ready to point their telescopes toward the event. Space telescopes such as the Hubble Space Telescope and the James Webb Space Telescope will provide detailed images of the explosion. Ground-based observatories will measure a significant increase in brightness and detect accompanying surges in gamma rays and X-rays. Radio telescopes will register dramatic changes in the radio wave spectrum. Gravitational wave sensors, which detect tiny ripples in the fabric of spacetime caused by cosmic events, are expected to pick up signals from the explosion even before it becomes visible. Gravitational waves are produced by moving matter and are incredibly subtle, making their detection a significant achievement in understanding cosmic events. Additionally, unusually high neutrino currents, which are subatomic particles that travel close to the speed of light, are likely to be detected by the world's most advanced neutrino detectors located in the Arctic and Antarctic. Following the explosion, Betelgeuse will disperse an immense amount of matter and energy into space. The star's outer layers will be expelled across the galaxy, traveling over billions of kilometers and light-years. The impact of the blast wave on Betelgeuse's immediate surroundings will be significant, but the vast distances in the universe mean that neighboring stars may not experience severe damage. Betelgeuse's explosion will be the first red supergiant supernova observable directly in our cosmic neighborhood, providing a unique opportunity to study the event with modern technology. In the aftermath, Betelgeuse will remain visible as an exceptionally bright spot in the sky for several weeks to months. Its brightness will gradually decrease over time, eventually fading from view. Despite its disappearance from the naked eye, astronomers will continue to monitor the star's remnant with telescopes. Betelgeuse will likely leave behind an extremely compact remnant, either a neutron star or a black hole. The explosion might also form a spectacular cosmic nebula, such as the colorful Crab Nebula. These nebulae can persist for millions of years, serving as a lasting reminder of the star's life and death and providing valuable material for further research. To understand Betelgeuse's future explosion, it is helpful to look back at its life. Approximately 10 million years ago, Betelgeuse was born in a dense molecular cloud composed of gas and dust. This cloud, containing remnants of earlier supernovae, collapsed under its own gravity, forming a protostar. Over time, the protostar accumulated more mass until nuclear fusion began, marking the birth of Betelgeuse. It was not alone. Betelgeuse was part of a star nursery, a chaotic and luminous region filled with newborn stars, reminiscent of today's Orion Nebula. As a massive star, Betelgeuse had a shorter lifespan compared to smaller stars. It burned through its fuel rapidly, releasing enormous amounts of energy as hydrogen atoms fused into helium in its core. This phase lasted only a few million years, a brief period in cosmic terms. During this time, Betelgeuse was likely a blue supergiant, thousands of times hotter and brighter than the Sun. As Betelgeuse progressed in its life cycle, the hydrogen in its core was exhausted, leading to the fusion of helium into carbon and oxygen. This marked the beginning of Betelgeuse's transformation into a red supergiant. The star's outer layers expanded significantly, and it began to lose substantial amounts of matter through strong stellar winds. At this stage, Betelgeuse's diameter surpassed the orbit of Mars around the Sun. Its bright red color fascinated observers on Earth. The expansion of Betelgeuse and its increasing brightness likely had a profound impact on any planets that may have orbited it. As Betelgeuse grew, its outer layers would have swallowed the inner planets, and any potential life on those planets would have been destroyed by the star's intense radiation. Betelgeuse's transformation involved the fusion of heavier elements such as carbon, neon, oxygen, and finally silicon into iron. This process accelerated, with each fusion stage producing less energy. As the star became heavier, it eventually collapsed under its own gravity. The collapse led to a catastrophic explosion, releasing an immense amount of energy in a fraction of a second. This explosion would be a breathtaking cosmic event, the true scale of which is difficult to grasp fully. The timing of Betelgeuse's explosion remains uncertain. While it is evident that the star is in its final phase of life, predicting the exact moment of the explosion is challenging. Astronomers are using various telescopes and technologies to observe Betelgeuse closely. The Hubble Space Telescope, the James Webb Space Telescope, the European Southern Observatory's Very Large Telescope, and the Atacama Large Millimeter/Submillimeter Array, ALMA, in the Atacama Desert are all contributing to this effort. Observations have shown changes in Betelgeuse's brightness, including a significant dimming between late 2019 and early 2020, which sparked speculation about an imminent supernova. This dimming was later attributed to factors such as a large cloud of dust ejected from the star and cooler regions on its surface. A subsequent, less dramatic dimming in 2024 is thought to be a residual effect of the 2020 obscuration. These phenomena highlight the star's instability and serve as crucial clues that Betelgeuse might soon explode, or may have already done so, with its light still on its way to Earth. The eventual explosion of Betelgeuse will bring a dramatic change to the Orion constellation, one of the most recognizable and significant patterns in the night sky. In Greek mythology, Orion is depicted as a mighty hunter, loved by Artemis, the goddess of the hunt. This constellation symbolizes strength, courage, and adventure, and Betelgeuse, with its striking red color, has inspired countless stories and legends. The transformation of Betelgeuse from a familiar, protective star into a dazzling supernova and ultimately a void in the sky will mark a significant shift. This change will remind us of the universe's constant flux and the cyclical nature of cosmic events, where even the seemingly eternal stars are subject to birth, life, and death. In conclusion, the explosion of Betelgeuse will be a monumental event, offering a rare opportunity to observe and study a supernova in our cosmic neighborhood. The brightness and impact of the explosion will be extraordinary, altering the night sky in ways that are both awe-inspiring and transformative. As astronomers continue to monitor Betelgeuse, the anticipation of this event serves as a reminder of the dynamic and ever-changing nature of the universe. The eventual explosion will not only provide valuable insights into stellar evolution but also change our view of one of the most iconic constellations in the night sky. Subscribe to the channel now for more exciting videos to come.